Can you
Yeah,
hear
good
me?
evening, sir.
Yeah, good evening. Uh, okay, we'll wait for 1 or 2 more minutes for
Hmm.
people to join in. Okay, so in the first class, we were beginning our discussion of quadratic equations. We had discussed basic things that you have learned in 10th grade uh, about quadratic equations, sum of roots, product of roots, how the formula comes. Those things are obvious, and I'd asked you guys to read the theory of this module as much as you can. Did you guys read anything here?
Yeah, sir. Till inequalities.
Till where?
Inequalities are there, right? There.
Till page number what in the sheet?
Sir, 14.
Saif, how much have you read?
सर अभी पेज नंबर 4 तक पढ़ लिया सर।
पेज नंबर 4। फोर फोर तक तो कुछ है ही नहीं, फिर क्या पढ़े हो फिर?
सर वो थोड़ा स्कूल में होमवर्क था तो।
स्कूल में होमवर्क? क्या होमवर्क था स्कूल में?
सर वो थोड़ा केमिस्ट्री के मैम ने थोड़ा होमवर्क दे दिया था बट सैटरडे तक कर लूंगा सर।
ये सब सब स्कूल में क्या चल रहा है और बारिश हो रही है, ये सब सबसे हम लोगों को कोई मतलब नहीं है, ठीक है?
यस सर।
उससे हमारे क्लास पे कोई इफेक्ट नहीं पड़ना चाहिए। स्कूल में क्या हो रहा है उससे मुझे क्या मतलब है? मुझे चाहिए कि क्लास में तुम आए हो तो जितना बोला गया है उतना करके आओ। समझ रहे हो ना?
यस।
काफी दिन हो गए हैं। व्हाट यू हैव डन इज नॉट इनफ एंड यू नीड टू कम प्रिपेयर्ड फॉर क्लास।
ओके
ऐसे
सर।
ही ऐसे ही आओगे तो फिर क्लास नहीं कर पाओगे तुम।
यस सर।
ओके। आदित्य, तुमने कहाँ तक पढ़ा है?
सर ज़्यादा नहीं पढ़ पाया, मेरा कल एग्जाम इसलिए।
बोर्ड एग्जाम?
यस सर, साइंस का लास्ट है सर।
तो कल एग्जाम है तो फिर आज कैसे क्लास अटेंड कर रहे हो गया तैयारी?
सर अभी 2 चैप्टर्स रह गए हैं लास्ट, हो जाएगा सर।
हो जाएगा मतलब अभी 9:30 हो गए, कब है एग्जाम?
सर कल 9 बजे से।
तो अभी यहाँ पे क्लास अटेंड करने की तुमको जरूरत नहीं, कल तुम्हारा बोर्ड एग्जाम है, अभी तुम क्लास क्यों अटेंड कर रहे हो? जाके
इजी
तैयारी करो जो
चैप्टर्स है
चैप्टर
सर,
बचा है।
इजी चैप्टर्स रह गए हैं बस, 1 आवर में हो जाएंगे।
हाँ, ये वाला वीडियो बाद में देख सकते हो, अभी जाके एग्जाम की तैयारी करो ना, बोर्ड एग्जाम है ना कल।
यस सर।
हाँ, मैं बोल रहा हूँ अभी जाके तैयारी करो एग्जाम की।
ओके सर।
ठीक है, ये वीडियो बाद
ओके।
में देख लेना, ऐसा कुछ सब बाद में दिख जाएगा तुमको। ठीक।
ओके सर।
हम्म। यू कैन लीव द मीटिंग, इट्स फाइन। ओके, फाइन। सो we'll start off with the first thing, which is about we were discussing nature of roots. And one thing that is important to know is a property of the roots where if A, B, C are rational, then the irrational roots, what can you say? Then the irrational roots of this quadratic will,
Sir, it pairs like
right, the irrational roots of this quadratic will come in pairs. One root will be the conjugate of the other. So for example, if this quadratic equation has c plus root d, which is irrational number, and that is a root, then you can say that it is guaranteed that c minus root d will also be a root. But the condition for that to happen is that a, b, and c, the coefficients have to be rational number. I have said by mistake roots, they have to be a rational number. Why is that? explain this property. If you have read the theory, you should be able to explain it, or if you have understood it. ये प्रॉपर्टी कहाँ पे है पता है ना सबको? ये पे पॉइंट नंबर 3 पार्ट बी है.
यस सर.
सो किसी को समझ में आ रहा है कैसे क्यों है ऐसा प्रॉपर्टी?
हम्म.
अनिकेत तुम कुछ बोल रहे हो?
यस सर, यस सर.
क्या है रीजन?
तो अगर एबीसी रैशनल है तो फिर सर इरेशनल के लिए डी परफेक्ट स्क्वायर होगा नहीं, तो फिर वो कॉन्जुगेट में होंगे ना सर.
क्या बोल रहे हो? डी परफेक्ट स्क्वायर होगा नहीं मतलब?
सर अगर डी परफेक्ट स्क्वायर नहीं होगा तभी वो कॉन्जुगेट में है ना.
तो उससे सी कैसे गारंटी है कि सी यहाँ पे बराबर होगा?
नहीं सर, अगर कोई भी जो रूट्स है वो कॉन्जुगेट में है तो सर उसका जो सी है वो हमेशा वाई एक्सिस पे ही लाई करेगा.
तुम तुम क्लियरली ये नहीं बोल रहे हो कि तुम्हारा असम्पशन क्या है और तुम बता क्या रहे हो? अभी तुम क्या अज्यूम कर रहे हो?
नहीं सर, मैं अभी
ऑलरेडी
तो अज्यूम कर रहा हूँ
कॉन्जुगेट
कि
पेयर्स है
एबीसी.
रूट्स, अगर बोलोगे तो फिर प्रूव क्या कर रहे हो?
हम्म.
मतलब ऑलरेडी जो चीज प्रूव करना है उसको अज्यूम थोड़े कर सकते हैं. व्हाट आई वांट यू टू टेल मी इज, इफ A, B, C are real rational numbers, then if E plus root D is a root, then this will also be a root. You cannot say this by already assuming that conjugates roots हैं. कुछ समझ में आ रहा है मैं क्या बोल रहा हूँ?
यस
यस
सर.
सर.
You need to prove it properly, not by like fake stuff. सैफ क्या रीजन है?
सर वो डिस्क्रिमिनेंट का फॉर्मूला होता है, मतलब कि माइनस बी प्लस माइनस रूट डी अपॉन टू है. तो
हम्म.
अगर मतलब सर वो रूट में आ गया तो एक तो माइनस बी प्लस रूट डी अपॉन टू ए हो गया, और तो दूसरा नेचुरली माइनस बी माइनस रूट डी अपॉन टू ए ही आएगा. तो अगर वो अंडर रूट के अंदर कोई भी चीज आ गई तो वो मतलब ऑब्वियसली प्लस और माइनस में रहेगा, तो सर हो सकता है वही रीजन.
हाँ. Another way to say it, or another way to understand it better, is if this is my equation, I know sum of the roots is what? And I also
माइनस
know
बी अपॉन.
product of the roots is C over A, right? अगर sum of the roots और product of the roots ऐसा है, और तुमको पता है कि A, B and C are rational, तो राइट हैंड साइड दोनों का रैशनल है कि इरैशनल?
सर रैशनल.
राइट हैंड साइड रैशनल है यहाँ पे भी और यहाँ पे भी. अगर रैशनल है राइट हैंड साइड, तो इरैशनल अगर कोई एक रूट अल्फा है, इरैशनल, मान लो वो इरैशनल है p प्लस रूट क्यू, तो हाउ कैन यू ऐड अनदर रूट टू इट टू मेक इट रैशनल?
लेकिन सर
माइनस
अगर हम
रूट.
अज्यूम करें कि एबीसी तीनों इरेशनल है तब.
क्या बोल रहे हो?
अगर हम पहले से अज्यूम करें कि एबीसी तीनों इरेशनल है.
अभी हम लोग क्या बात कर रहे हैं, तुम क्या बोल रहे हो?
नहीं सर, आपने तो मतलब वो तो इसमें लिखा है ना कि एबीसी रैशनल नंबर है तब इनके रूट कॉन्जुगेट में है. लेकिन सर अगर हम इसी को इरेशनल में देखें तो फिर यहाँ पे तो प्रॉपर्टी सेटिस्फाई हो रही है ना, अगर एबीसी रैशनल है तो.
अभी एबीसी रैशनल है कि इरैशनल है?
इर इर इरेशनल. तब तो फिर आरएचएस और एलएचएस दोनों वो हो रहा है इरेशनल, तो यहाँ पे तो फिर सेटिस्फाई हो जा रहा है.
तुमको कुछ समझ में नहीं आ रहा है मैं क्या बोल रहा हूँ. तुम पूरा कंफ्यूज हो चुके हो. मैं बोल रहा हूँ अगर ए बी सी आर रैशनल, जो लिखा है वही बोल रहा हूँ. इरैशनल कौन बोल रहा है? इफ ए बी सी आर रैशनल, राइट हैंड साइड रैशनल होगा कि इरैशनल होगा?
सर अभी रैशनल है।
तो अभी अगर रैशनल है तो हाउ कैन यू हैव टू रूट्स add together to become rational? If one of them is irrational, the other one is forced to be what?
टू
Can it be
कॉन्जुगेट।
rational if one of them is irrational?
नहीं नहीं नहीं।
So other one is forced to be irrational.
हम्म।
And what kind of irrational does it have to be? So that when you
कॉन्जुगेट ऑफ
add
द
it, it
फर्स्ट वन।
becomes rational.
द कॉन्जुगेट ऑफ
माइनस
द
रूट।
फर्स्ट वन।
It is guaranteed that P का कुछ बोल नहीं सकते हैं, लेकिन यहाँ पे S माइनस रूट क्यू होना पड़ेगा,
हम्म।
राइट?
यस सर।
माइनस रूट क्यू पार्ट आना चाहिए ताकि ऐड करके कैंसिल हो जाए और रैशनल बन जाए वो। सिमिलरली
हम्म।
अगर प्रोडक्ट को रैशनल बनाना है तो S विल हैव टू बी इक्वल टू P। तुम अगर
हाँ।
इसको और इसको मल्टीप्लाई करोगे तो क्या होगा? इरैशनल हो जाएगा वो।
हम्म।
So that means it is guaranteed that beta has to be P minus root Q. And this property is not valid. There is no guarantee that irrational roots will come in pairs if the coefficients have any one irrational term. Do you understand what I'm saying?
यस सर।
यस।
The guarantee is there only if the coefficients are rational. Same
हम्म।
property will be applicable also in the case of different number system. If A, B, C are real and one of the roots is complex, one root is complex and is A plus IB, the other root is now forced to be A minus IB.
ए माइनस आई बी बाय द
For
सेम
the
मेथड।
same reason that the sum of the roots and product of the roots is real.
हम्म।
सबको समझ में आ रहा है मैं क्या बोल रहा हूँ?
यस सर।
यस।
That is what is explained in this point. Then we go ahead. Roots under particular cases is just many cases they have shown, nothing major. You have to read it, but nothing to remember here. All of it is logical and you can figure it out. You don't have to remember anything here. By the way, Rudrojit, are you there? Rudrojit, can you hear me? So these sheets, you will have access to it in the drive, Google Drive. I hope you have checked out the Google Drive. In that, in the theory module section, you will get the quadratic equation sheet that we are currently discussing. So you should open that. From there, you can see the sheets. Okay, we go ahead and we will go to point number 5. 5 में क्या है? Identity. So the point is that sometimes you can say that a quadratic equation is not an equation, it is an identity. Difference between an identity and an equation is that identity is valid for all values of x. Valid for any x. Whereas an equation is valid for only some values of x, right? When you have a quadratic equation, the fundamental theorem of algebra says that any n degree equation can have at most n real roots. So quadratic equation का degree है 2, so it can have at most 2 roots. No, actually, I have said the fundamental theorem wrong. Fundamental theorem says any n degree equation has n roots. Real or complex doesn't matter. Total number of roots is n. Similarly, quadratic equation has 2 roots, right? Maximum.
Is it any reason behind it that n roots
There is
only?
a proof of fundamental theorem of algebra, and the proof is right now beyond your level. So the main theorem of algebra is this, that n degree equation have n roots.
यस।
Because obviously n degree equation will be factored into n simple terms. Quadratic equation can be factored into 2 terms, right? The nth degree equation can similarly be factored into n different factors. Each of the factors will give us one root. However, if somebody says that this equation has 3 roots PQR, that is a direct violation of the fundamental theorem of algebra. N degree equation cannot have n plus 1 roots, right?
Yes, sir.
So whenever this is happening, actually this means that this equation is not really an equation, it is an identity. If it was an equation which was valid for only some values of x, then it is impossible to have 3 different values of x, right? Is it clear what I'm saying?
हम्म,
सैफ तुमको समझ में आ रहा है?
हाँ सर।
अगर इक्वेशन क्वाड्रेटिक इक्वेशन के 2 से ज्यादा रूट्स किसी ने बोल दिया है, तो then it's not an equation, it's an identity. What is the meaning of an identity? It means any value of x पे ये fit होगा, ये सही होगा.
हाँ
Which means the only condition is that a is
तो
equal to b is equal to c is
इज टू
equal to
सी
0.
0, देन फिर ये क्वाड्रेटिक रही नहीं फिर।
The way this equation can fit for any given value of x, there is only one way, that all the coefficients are 0.
यस
There is
सर।
no other way for that to happen, because x can be any real number and it is still going to be valid. So that is what is being explained in this section. So anytime you should be on the lookout ki, are you getting an equation which has more roots than 2? And if it is a quadratic, that means the equation is not an equation, it is an identity. And then you can use the fact that a and b and c have to be 0.
ओके
Then the next point is about common roots. Point 6 is about common roots of two quadratics. So what do we mean by common roots? You are given two quadratics, a1x squared plus a2x plus or b1x plus c1 equals 0, and another quadratic a2x squared plus b2x plus c2 equals 0. Now it is possible that this quadratic has roots alpha beta and this quadratic has roots alpha gamma. In that case, we will say that they have one common root alpha.
यस सर।
Our job is to find out the condition on the coefficients a1, b1, c1, a2, b2, c2, so that they have one common root. Given any two quadratic equations, what is the condition that they will have a common root? So that is what we will try to figure out right now. So the way to do it, you need to know the method to do it. Don't try to remember the condition. If you try to remember the condition, you are guaranteeing yourself silly mistakes. फॉर एग्जाम्पल 6 पार्ट
ओके
ए में उसने कंडीशन लिखा है लेकिन उसको याद नहीं करना है. समझ रहे हो ना? आई होप
यस सर।
एवरीबडी कैन सी द मॉड्यूल.
यस सर।
6 part A, the condition that has been given, don't try to remember it. Whenever the situation arises, you have to do the derivation. And the derivation is actually very simple. You will say alpha is a root of the first equation. So a1 alpha square plus b1 alpha plus c1 is 0. And alpha is also a root of the second equation. So a2 alpha square plus b2 alpha plus c2 is 0. Is everyone understanding that these two equations are valid?
यस सर।
Okay. So from here, what we will do is we will eliminate alpha and get a relationship based simply on the coefficients. How do we eliminate alpha from these two equations? That is what we will learn. So first is solve for alpha. Second step is solve for alpha squared and then use both relations together. So I will show you what to do. So what do I mean solve for alpha? Think of alpha square as a different variable and this is a different variable. I want you to solve for this variable, which means you should eliminate which variable?
Alpha square.
You should try to remove alpha square from this equation. How can we eliminate alpha square? I should multiply first equation by a2,
By A2 and second by
second
A1.
equation by a1, and I should subtract. If I
Yes, sir.
do that, first term will become a1 a2 alpha square, and here also a1 a2 alpha square, and it will get eliminated, right?
Hmm.
And you will get b1 a2 minus b2 a1 alpha is equal to c2 a1 minus c1 a2. And from here you get alpha is equal to c2 a1 minus c1 a2 divided by b1 a2 minus b2 a1. Right?
Yes.
Similarly, second
So
step is
divided by
solve for
B1
alpha square. So
Yes,
this
sir.
time I will eliminate alpha, right?
Hmm.
I will
Yes, sir.
multiply by b2 and multiply by b1 and subtract, and I will get a1 b2 minus a2 b1 alpha square is equal to b1 c2 minus b2 c1. So alpha square is coming out to be b1 c2 minus b2 c1 by a1 b2 minus a2 b1. Right? This is your second condition.
Okay.
This is your first condition. And notice that now it is very easy to eliminate alpha altogether from the equation. Because we can say that alpha from here, this thing square will be equal to this thing, right?
Okay.
Are you understanding what I'm saying?
Yes, sir.
We can easily say that this square C2A1 minus C1A2 by B1A2 minus B2A1 square should be equal to B1C2 minus B2C1 by A1B2 minus A2B1. And that basically gives us the condition for the two quadratics to have one common root. If the quadratics were like this, and another quadratic is like this, and somebody says that they have two common roots, or both roots are common, that is pretty obvious. The condition is easy in that case. Since both roots are common, either both the equations are same or they are different only by some factor, right?
The ratios are same. A1 by A2 is equals to
So
B1
then
by
the ratios of the coefficients must be same. A1 by A2 should be equal to B1 by B2, should be equal to C1 by C2. Why are we saying that the ratios are same? Because if the second equation is some multiple of the first equation, like k times a1 x square plus k times b1 x plus k times c1 equals 0, you should realize that this equation also has the same roots as the first one, right?
Yes, sir.
Yes.
So this is a simple condition for both roots being common. We already know how to do when one root is common, right?
Okay.
Okay, then what I want you guys to try out now is question number, do yourself 4, question number 2.
Question number?
Question number 2, which says if x square minus 7x, okay, actually it's very easy. So maybe you should not try that. Question number 3. Question number 3 is show that x square plus a square minus 2x minus 2a square is equal to 0, and x square minus 3x plus 2 is equal to 0 have exactly one root in common. have exactly one root in common for all A belongs to real. It is obvious that the second equation has roots 1 and 2.
And
Now you
the
should check whether 1 or 2 is the root of this, right?
2 is the root.
If you put 2 into it, you'll get 4 plus a square minus 2 into 2 minus 2a square equal to 0. So you get 2a square minus 4. So it is clearly fitting, right? 2 is a root. And then now you have to check for 1 also. If you put 1, what happens? 1 plus,
No, it's not.
right? And this is becoming minus a square minus 1, which is not equal to 0 clearly, right?
Yes, sir.
So that means 1 is not a root, while 2 is a root. So that means it has one common root. So actually it is simple only. There is no issue here. The next point is remainder theorem. Remainder theorem is a general idea. Remainder and factor theorem. Factor theorem says that f of x equals 0 has a root p implies x minus p is a factor of f of x, right? And this factor theorem is a consequence of remainder theorem. Remainder theorem actually says, remainder theorem says that when you divide f of x on when we divide f of x by x minus p, the remainder obtained is f of p. So what we are saying here is technically if you divide f of x by x minus p is the divisor, f of x is the dividend. So there will be some quotient polynomial q of x, right? Plus some remainder polynomial r of x. Do you understand what I'm saying?
Yes.
The only thing that is guaranteed is that the remainder polynomial will have a lower degree
Then the polynomial from which we are dividing.
Then this. So actually, if you're dividing with a linear thing, remainder is a constant.
Hmm.
If you're dividing with a linear x minus p factor, remainder is a constant. If this was a quadratic, remainder could have been a linear polynomial also, right? I hope everyone is understanding what I'm saying.
Okay, yeah.
ऐसा अगर
Rem-
तुम एक f of x को x square minus 2x plus 3 से डिवाइड करोगे तो रिमाइंडर could be a function of x, right?
हाँ,
Remainder could be something like 3x plus 4 or something, right?
okay.
But अगर तुम एक f of x को x minus 3 से डिवाइड करोगे तो रिमाइंडर का डिग्री has to be lesser than the degree
linear.
of this,
हाँ, हाँ, वो एक
which
कांस्टेंट
makes it
रहेगा.
a constant,
Sorry.
right?
Okay.
Yes, sir.
So the point is that this idea is exactly like normal division of numbers जो तुमने 10th ग्रेड और उससे पहले भी यूक्लिड्स डिवीजन एल्गोरिथम जो होता है a is equal to bq plus r, right?
Hmm.
When
Yes,
you
sir.
divide a by b, you get a quotient and a remainder. What is guaranteed is remainder is like this.
Hmm.
So same thing we are saying, f of x instead of a, q of x is the quotient, x minus p is what I am dividing it with, and that is in place of b, and then you'll get a r, right? Some remainder. If the divisor was higher degree, I would say it could be r of x in general, right?
Sir, if it would be quadratic or biquadratic, then we can say R of X, yes.
If it is a higher degree thing, then we will say it's a polynomial remainder is possible, right?
Hmm.
As long as the degree of this remainder is less than the degree of the divisor.
Yes, sir.
That's the condition. Now, if I have this situation, in this equation, I will put x is equal to p. So notice that we are getting f of p is equal to 0 plus r, right?
R.
Because this is a remainder, this is not a polynomial right now. This is a
Hmm.
constant right now because we are divided by this.
Hmm.
So we are getting f of p is equal to 0 plus r. So basically the remainder is clearly f of p.
Yes, sir.
So that is a consequence, that is remainder theorem. And if the remainder was 0, if remainder was equal to 0, then obviously f of p is 0, right?
Yes, sir.
F of p is 0, which means that f of x
P is
has a root
factor.
p.
P is a factor.
So basically remainder theorem and factor theorem are deeply linked to each other. They come from the same idea. And the idea is similar to in number theory when we say we divide a number by another number, we get a quotient and a remainder. Same thing you're doing, but this time you're doing it to polynomials.
Hmm.
Sir, यहाँ पे p is will be constant or it can be any other variable also.
P.
You cannot divide things by another variable.
Constant.
कहाँ से लाओगे? Constant ही होगा ना?
Constant. हाँ.
Okay, sir.
Another variable मतलब y थोड़े है फिर. If you divide by another variable, then it is going to, then your original thing should also have had some y and all, right? It will be totally weird if you try to divide a function of x by x minus y. Do you understand
Yes.
what I'm saying?
Yes.
I mean, you can still write something, but it will not be very meaningful.
Yes, sir.
Okay. The next section is inequalities. There is nothing to do in terms of theory here. You just need to understand the method of solving inequalities, which is known as the wavy curve method. So basically, the idea is simple. If you have a rational inequality, which involves algebraic expressions, it will be something like this. Let's say x minus alpha, x minus beta by x minus gamma greater than equal to 0. If it was something like this, all we have to do is think of all of the points where this inequality is going to become equal to 0, or where each factor can become 0. So the 3 points under consideration are
alpha, beta,
alpha,
gamma.
beta, and gamma.
But gamma
Gamma
can't
is
be,
not
sir.
an allowed
Ah,
point because it makes a denominator 0.
0.
But you can go near gamma, you cannot equal to gamma though. All of these points are points where the factors will change signs. Ahead of alpha, x minus alpha will be positive, and before alpha, it is negative, or left or right of alpha. Similarly, left or right of beta, this is positive or negative. Left or right of gamma, this is positive or negative. Ultimately, in solving inequalities like this, all you have to do is draw a number line, see which values are allowed. For example, here gamma is not an allowed value. And after that, see what inequality you want to make it come to, and accordingly take which range of x is going to fit. For example, here, this is
Okay.
x greater than gamma. For x greater than gamma, all three are positive. So this is positive here. Between beta and gamma, what is happening?
For alpha, it is positive, x minus alpha, and for x minus beta, it is positive, but for x minus gamma, it is negative.
This is positive, this is
This is negative,
negative,
and that
and
is
this is
positive.
positive. So overall inequality, overall fact expression is negative. Here it will be positive, here it will be negative, and therefore our answer will be x greater than gamma and x belonging to alpha to beta region. In these regions, you will make sure that this inequality is true.
Okay.
All you have to do is see where are the points where the factors that you have are changing their sign, and accordingly you have to put them on the number line and figure out when the inequality will be satisfied.
Got it.
There is nothing major to it. Sometimes you might see a situation where you might have a quadratic and all. If you have a quadratic situation happening, the
And then,
quadratic can be thought of in terms of its roots and all.
and then, sir, this one can be is greater than 0, so it can be, yeah, always greater than 0.
This is always positive, so you can ignore it. You don't need to worry about factors which are always going to be positive, because that will not affect the sign of the inequality. Even if you had something like this, if this is
Right,
always positive, I can ignore it and I can focus on these two, right?
sir.
Is it clear what I'm saying?
Sir, if it was always negative, then what would happen?
You will change the sign of the inequality.
So we can ignore that also after changing the sign of equality.
If something is always negative, are you guaranteeing knowing that always the sign is minus here? If you
No, sir,
already know that something is already negative always, then you have to accordingly calculate other factors to make your inequality true. Do you understand what I'm saying?
sir, but can't we not multiply negative on the both side and flip the inequality also? Then it will work as always positive, and then we can ignore that.
मल्टीप्लाई करना जरूरी है, उसको बिना मल्टीप्लाई किए नहीं हो पा रहा है.
हाँ, मतलब वैसे भी रख सकते हो, पूछ रहा था.
तो दो स्टेप्स करने की क्या जरूरत है जब एक स्टेप में हो रहा है? अगर
हम्म
तुमको ऑलरेडी साइन किसी चीज का पता है तो उसके बारे में क्या फिर चिंता करना है?
हम्म
बाकी का सोचो कि बाकी में क्या होना चाहिए. Do you understand what I'm saying?
Yes, sir.
You don't have to do operations on it to make it positive. Do you understand?
Yes, sir.
So solving inequalities is about practice, and you need to do some questions to get a hang of it. It will not happen by talking about it or reading theory. For example, solve part D right now. Do yourself 5.
5. Okay.
Do yourself 5 part D. There are a lot of terms. Make sure that you don't make any mistakes and get the correct answer. You have to solve this inequality.
Solving, sir. Done.
In this thing, you can always ignore the sign of this because it's a square. You can ignore the sign of this because it's a square. And you can also ignore the sign of this because 2x squared plus 4x plus 9 is always going to be greater than 0.
हाँ.
Why? Because its discriminant is less than 0. Discriminant is 16 minus 4 into 2 into 9. So that is
And
clearly
A is
less than 0.
positive.
So it has no real roots. So it's always positive. Or you can see it by completing the square.
Mm-hmm.
You can see 2x squared plus 4x plus 2 plus 7 is equal to 2 times x plus 1 whole square plus 7, which is clearly always greater than 7. So these things are anyway removed because the sign of them cannot affect anything. They are always positive. So the ones that we have to worry about are these factors. There are 5 factors and we have put those 5 points on the number line. Now, if you look at it, when x is greater than 9,
Positive.
this is positive, this is positive, this is positive, this
Positive.
is
Positive.
positive, but this is negative.
Negative.
So the overall thing here is negative. 4 positives, 1 negative. When it is below 9 and above 2, this is still negative, but this becomes also negative. Right? So the overall thing becomes negative, negative, and 3 positive. So it is overall positive here. And now the
Yes,
signs
sir.
will keep alternating. And the required answer will be between -6 and -3, not including -6 because it's in the denominator, not including -3 also because it's a strict inequality, right? This region and this region, not including half and 2 because it's a strict inequality. These are the two regions for which, or actually there is a third region which is this region. X is above 9. All of these regions, again, not including 0. Is it clear to everyone what we have done?
Yes, sir.
Saif, are you understanding what I'm saying?
सर वो x⁴ और 1 - x² को क्यों हटा दिया सर?
उसका क्या होगा साइन?
सर अगर x को 0 कर देंगे तो वो सर इन्फिनिटी हो जाएगा फिर तो।
0 करना अलाउड है?
नहीं।
नो सर।
तो फिर उसका बात क्यों कर रहे हो? साइन क्या होता है x⁴ का और 1 - x² का?
सर पॉजिटिव।
तो पॉजिटिव साइन की चीज से हमारा कोई इफेक्ट आएगा इनइक्वालिटी सॉल्व करने में?
नो सर।
इसीलिए हटा दिया उसको। पॉजिटिव साइन
और
भी
सर ये
पता है कि हर समय साइन पॉजिटिव है तो उसमें कुछ सॉल्व करने की जरूरत है उसको?
नो।
It's almost like it's a number constant, right?
और सर ये 2x - 1 और 2 - x को उल्टा नहीं कर सकते, मतलब x - 2 और x मतलब 1 - 2x कर देंगे तो?
1 - 2x से फायदा नहीं होगा ना कुछ।
उल्टा करने का कोई पॉइंट नहीं है, सीधा करके
वही।
जैसे हो रहा है डायरेक्टली, तो फिर क्या दिक्कत है?
1 - 2x मतलब सर 2 को कॉमन लेके हटा दिया और मतलब फिर x - ½ हो गया सर वो, और दूसरा वाला x - 2 हो जाएगा, मतलब 2 - x की जगह पे तो माइनस माइनस फिर कट के प्लस ही हो जाएगा सर।
क्या बोल रहे हो भाई? यहाँ पे 2 कॉमन लेके x - ½ हो गया और यहाँ पे क्या कर रहे हो?
हाँ सर x - 2।
तो उससे फायदा क्या हो?
सर फिर इनइक्वालिटी पलट जाएगी, मतलब एक नेगेटिव बाहर आ गया तो वो 0 हो जाएगा, >0 हो जाएगा।
नहीं, ये सब करने का फायदा क्या हो रहा है? अभी जो सॉल्व कर रहे हैं उससे कुछ फास्टर हो रहा है क्या?
नो सर।
अभी जो मैंने सॉल्व किया उससे फास्ट तुम्हारा आंसर आ रहा है क्या उसमें? कि फाइनली फिर से ये पॉइंट्स ऐसे डालना है नंबर लाइन पे?
समझ गया सर।
समझ में आ रहा है कुछ क्या बोल रहा हूँ?
यस सर।
अंत में पांचों पॉइंट्स को नंबर लाइन पे डालना तो है ही ना?
यस सर।
तो फिर इतना ऑपरेशंस करके केयरलेस मिस्टेक करने की कोशिश मत करो।
ओके सर।
बस देखना है कि किस रीजन में कौन सा फैक्टर पॉजिटिव है, किस रीजन में कौन सा फैक्टर नेगेटिव है, और उसके हिसाब से ओवरऑल पांचों टर्म्स का साइन क्या हो रहा है, राइट?
यस
गॉट
सर।
इट।
अगर ये केयरफुली सही सही देखोगे तो आंसर सही सही आएगा, और इसमें कुछ है नहीं। When
ओके
you
सर।
solve more problems, you will get more experience. The only thing to be careful about in inequalities is, for example, part E अगर तुम देखोगे, पार्ट ई, उसमें है 7x - 17 / x² - 3x + 4।
तो इसमें -1 1 को लाइक माइनस में ले आएंगे तो फिर ऊपर एक क्वाड्रेटिक बन जाएगी एंड नीचे एक क्वाड्रेटिक बन जाएगी, फिर उसको अलग अलग
हाँ,
वैसे
तो
बिहेव
वो
करेंगे।
सही है, लेकिन यहाँ पे बहुत लोग करते हैं ऐसे। ये गलत क्यों है?
क्योंकि इसमें पता नहीं है ना कि सर हम x² - 3x + 4 पॉजिटिव रीड करेगा या नेगेटिव।
बाकी लोगों को समझ में आ रहा है क्यों ऐसा का नहीं करना है?
सर सही तो है सर।
गलत है, यही तुम गलती
अच्छा।
करने वाले हो।
अच्छा।
ये सही इसलिए नहीं है क्योंकि तुमको पता है क्या इसका साइन क्या होगा? पहले से पता है कि ये पॉजिटिव है कि नेगेटिव है?
नहीं सर।
अगर पॉजिटिव है कि नेगेटिव है पता नहीं है, तो मल्टीप्लाई करते समय इनइक्वालिटी को रखना है ऐसे कि उल्टा करना है, पता है?
सर ये तो पॉजिटिव लग रहा है।
लग रहा है मतलब गारंटीड है हर समय पॉजिटिव रहेगा? लग रहा है मतलब के बेसिस पे सॉल्व नहीं कर सकते हो क्वेश्चन, श्योर होना पड़ता है ना।
सर x-3/2 का होल स्क्वायर ले लेंगे तो फिर तो प्लस समथिंग समथिंग आएगा इसमें, तो ये तो पॉजिटिव ही रहेगा।
तुमको डिस्क्रिमिनेंट नहीं आता है निकालना? वहाँ एक्चुअली डिस्क्रिमिनेंट नेगेटिव हो जा रहा है, मैं ही गलत बोल रहा हूँ। डिस्क्रिमिनेंट नेगेटिव हो जा रहा है यहाँ, राइट?
यस।
डिस्क्रिमिनेंट नेगेटिव हो जा रहा है तो ये हर समय पॉजिटिव है, लेकिन ऐसा हर समय होगा नहीं। अगर क्वेश्चन एज बिकॉज इट इज ऑलवेज पॉजिटिव, नाउ यू कैन डू इट। ओके, डू यू
ओके सर।
अंडरस्टैंड व्हाट आई एम सेइंग?
यस।
लेकिन अगर ऐसा क्वेश्चन रहता 7x-17
सर
बाय एक्स
3 से
स्क्वायर
7 की
माइनस थ्री
रेंज है,
एक्स प्लस टू
तब नहीं होता।
यहाँ पे अगर तुम मल्टीप्लाई करोगे ना तो गलत हो जाएगा पूरा।
यस सर।
क्यों गलत होगा? क्योंकि इसमें इसमें ये पॉजिटिव भी हो सकता है, नेगेटिव भी हो सकता है, तो तुमको केसेस लेने चाहिए, राइट? You should not assume that it is always positive and multiply it, right?
यस सर।
समझ में आ रहा है सबको?
हम्म
यस सर।
तो बेसिकली इस टाइप के क्वेश्चन में जहां पे डिनोमिनेटर यहाँ पे पॉजिटिव भी हो सकता है, नेगेटिव भी हो सकता है, उसमें हम लोग ऐसे करेंगे, x² - 3x + 2 -1 > 0, और सिंप्लीफिकेशन करेंगे नॉर्मल तरीके से, राइट? ये सिंप्लीफाई करोगे तो एक रैशनल एक्सप्रेशन आ जाएगा, और उसको तुमको वेवी कर्व मेथड से सॉल्व करना है, जो पिछला मेथड है उससे सॉल्व करना है।
हम्म
इज इट क्लियर?
गॉट इट। यस सर।
यस।
तो इसमें मल्टीप्लिकेशन और डिवीजन इनइक्वालिटीज में अवॉइड करना है कब? जब साइन श्योर ना हो। अगर साइन पता है पक्का से कि पॉजिटिव है या नेगेटिव है, तब तुम मल्टीप्लाई कर सकते हो, बट अदरवाइज you should try to do addition and subtraction instead of multiplication and division.
गॉट इट।
Okay, the next part is quadratic expression and its graphs. यहाँ से लेके 9 से लेके end of the theory तक पढ़ के आना है सबको अगले क्लास से पहले। End of the theory is on page number roughly till page 21 तक। Quadratic equation and its graphs till the end of the theory, I expect you guys to read and come. So make sure that you do the homework before the next class. समझ में आ रहा है ना सबको?
यस सर।
Read till the end of the sheet. I will be asking you what you have understood, what you have not understood.
ओके सर।
Okay, fine. The next class is, I think, on Saturday. I'll check the schedule and tell you. It was
यस।
decided to be on Saturday, right?
यस सर 1 PM।
सैटरडे एंड थर्सडे, सैटरडे 1 PM।
Right. हो सकता है उसमें थोड़ा सा टाइम का चेंज हो जाएगा, लेकिन 1 PM हो सकता है, नहीं हो पाए। I will let you know before if the time changes.
ओके सर।
Okay, that's all for now. I'll see you next time then.
थैंक यू सर।
थैंक यू।